Hi friends, today's lesson is from Chapter 1, Section 5. We'll discuss the distributive property. Our vocabulary today consists of term, like terms, equivalent expressions, simplest form, and coefficient. So a term is going to refer to one of these things. Check this out. I could have like 1/2 x squared plus, let's say, 5y to the third power and minus 6xy plus, let's throw r in there for good measure. What we notice here is we have these groupings of a number, basically, right, that are separated by addition and subtraction symbols. So what I want you to know is that each of these things that I'm highlighting in red or pink are considered terms. This is a four-term expression. These are terms. So terms are basically numbers that are separated by addition or subtraction in an expression, right? So all of this together, if I multiply 1/2 x to the second times x to the second power, that's going to be a number. All of these are individual numbers. At some point in time, we might call them something called monomials, and we can discuss that later. But these are terms. So when we talk about like terms, for instance, if we had this expression where we've got several terms here, 2x minus 4y plus 3 minus 7x plus 2y minus 1. So we've got 6 different terms here that we're looking at. Some of these terms are like terms. Like terms are terms where each of the variable portion of the number is the same. So for instance, this 2x is a like term to this minus 7x, and this 4y is a like term to this 2y, and this positive 3 is a like term to this negative 1. Also in this expression here, we have AB term, an AB term here, and an AB term here, and those two terms are considered like terms. So I'll highlight those like that. Just for instance, or just for reference, when I look at this AB term, I know that this is one AB term. So we know that we can put a little 1 here in front. Let me actually put a 1 here. That makes sense. So this is 1AB and 4AB. But let's take a look at this first expression that we talked about here. I'm going to grab it and put it over here real quick. Let's talk about equivalent expressions. So here's this expression. We saw what like terms were. The fact is, in algebra, you can join like terms together to create an equivalent expression. So this expression that I've rewritten here is going to be the same as the expression that I'm going to show you in a moment. So here's what we're going to do. We can take our like terms. This 2x and this minus 7x are like terms. When I add 2 plus a negative 7, what I get is a negative 5. So I'd get a negative 5x. And then I can deal with this other variable term, which is the negative 4y and 2y. These guys are like terms. And when I join these guys together, what I end up with is a negative 6y. Now I'm going to look at these two terms, which are like terms as well. And when I join these together, I end up with I end up with a positive 2 because I add 3 plus a negative 1 and I get a positive 2. So my answer here, negative 5x minus 6y plus 2, is said to be an equivalent expression to the one above it. So an equivalent expression is really simplifying your expression by sometimes joining like terms together like we did here and making kind of a more compact expression, right? These two have the same value, but this is a little bit more compact. So that brings us to the next idea of simplest form. So when I have an expression that is not simplified, it might be extended out, it might be kind of long. This compact form is considered the simplest form. So these are equivalent expressions, and we can replace one expression for another because they're equivalent by using or figuring out what the simplest form is. And the simplest form of this expression would be this one. The final term that we'll talk about today is coefficient. If we take a look at some numbers, let's say 1/2 xy or negative 3ab or 2rs or 7t or minus 1/3 z. All of these terms have something in common. They all have a coefficient. And let me actually put another one down. How about Q? All of these terms have a coefficient. I'm going to highlight the coefficient in each case. And so the coefficient here is the number next to the variable that I'm multiplying. So the coefficient here is 1/2. 1/2 is the number next to the variable in the variable term, the actual numerical value. -3 is the coefficient of AB. 2 is the coefficient of RS. 7 is the coefficient of T. -1/3 is the coefficient of Z. And what about Q? The coefficient of Q is understood to be 1. So we have a coefficient of 1 right here. I'll highlight that. All right, now that we've gotten through our vocabulary, let's go ahead, get started with some examples. Here in example 1, we're introduced to a concept called the distributive property, or the idea of distributing something. The distributive property basically says this: if you have a number A and you're multiplying it by the sum of two other numbers, let's say B plus C, or even the difference for that matter, so this could be A times the quantity of B minus C. Whenever you have a situation like that, you can evaluate this by doing a couple things. Of course, you can add the two numbers together and then multiply. Totally legit, totally what we would expect because of the order of operations. However, the distributive property tells us that this statement here is equal to A times B plus A times C. So I could write it like this: A times B plus A times C. If you choose some numbers, you can also prove, or at least convince yourself that it is true, that A times the quantity of B minus C is equal to the following: A times B minus A times C. So with the distributive property out and about, let's go ahead and try to handle this problem the way that the text asks us to. So I'm going to move this over here. So here we're asked to rewrite this using the distributive property. Well, looking right over there, I realize that I can simply rewrite this by multiplying 8 by 10, then 8 by 4. 8 times 10, I'd write like that, and then 8 times 4 like this. So we rewrote it using the distributive property. Now it's time for us to evaluate. So we remember, evaluate means to give a numerical answer. 8 times 10 is the first thing that we need to do. We're going to do multiplication left to right. 8 times 10 is 80, and 8 times 4 is 32. So we end up with 80 plus 32 is going to give us 112. And so that's our answer. So here in example 2, we're asked to distribute over subtraction. Sorry about this. We rewrite this using the distributive property, then evaluate. Notice over here, our term outside of the parentheses is on the other side. Still means to multiply. So distributive property also in this case can be applied, where 6 will be being multiplied by each term. Okay, so this is equivalent to 12 times 6 minus 3 times 6. And so now that we've rewritten it using the distributive property, we shall evaluate. 12 times 6 will give me 72. And 3 times 6 gives me 18. When I find the difference between the two, I get 54 as the result. I'm going to skip example 3 and go straight to example 4. Here we're going to use the distributive property. We're going to use this property to find each product, and this is kind of neat in a way. Some people actually think like this. Instead of doing a multiplication problem like 15 times 99, they kind of break it down into something similar, which we're going to do. So I know that 99 is equal to, 100 minus 1. And it's really super easy to multiply numbers by 100 and number by 1. So it makes sense for me to rewrite this problem as 15 times the quantity of 100 minus 1. Now that I've done that, I can use the distributive property, which says that this is an equivalent way of looking at this problem, right? And now I can just simply handle this problem in this way. Instead of doing long multiplication over there, I can say, oh, well, I know that 15 times 100 is 150. Just kidding, 1,500. And I also know that 15 times 1 is 15. And so now I can maybe more easier subtract 15 from 1500, and when I do that, I get 1485, and that's my final answer. Not too bad. Over here, we can try the same thing by looking at this this product rather, as 35 times 2 plus 1/5. So I've broken this number down, right? And now I'm going to rock the distributive property. And so when I do that, 35 times 2 is going to give me 70. And then 35 times 1/5, for a quick review of multiplying fractions rather, I'm just going to do this down here. 35 over 1, that's me writing 35 as a fraction, and then 1/5. And when we multiply fractions, we just go straight across from left to right. So 35 times 1 is 35. 1 times 5 is 5. When I divide 5 into 35, I'm going to get 7. So the next piece of this would be 35 times 2 is 70, but 35 times 1/5 is 7. So I'm going to add 7 to the mix to get 77 as my final answer. Here in example 4, we're asked to rewrite each product using the distributive property, then simplify, and that's if it's possible. So we're going to try that right now. The distributive property tells me that I can rewrite a problem that's being multiplied by a number on the outside of parentheses, basically, by distributing that number throughout the parentheses. So this becomes 5g minus 5 times a negative 9 is going to be negative 45. So we have 5g minus 45. Let's take a look at this problem here. Here we have negative 3, and it is being multiplied by many terms, by 3 terms right now. So I'm going to multiply negative 3 times 2 to the 2x to the second power, 2 times x squared, and what I get is a negative 6x squared. Then I'm going to take this negative 3 and multiply it by 4x, and I get a negative 12x. And finally, negative 3 times 1 gives me a positive 3. It says simplify, but there's no like terms to bring together, so right now we're done. And no, these guys are not like terms, even though they both have x. Let's take a look at this example number 6. We're going to combine like terms. If the terms are alike, you can bring them together. So if I have 15 x's, and then somebody says, hey, I've got 18 x's over here for you, and I say bring them over, meaning I'm adding them together, 15 plus 18 is going to give me 23. Just kidding again, 33. 33 x's or 33x. Let's look at this one. In this problem, we need to identify what exactly are the like terms, and I notice that this is n squared and this is n squared. These are alike. This n is not squared, therefore it is not like the others. So we can join these guys together, this 3n squared and 9n squared, but we can't join the 10n. So 3n squared coming together with 9n squared is going to give me 12n squared, and I'm going to add to that 10n, and that's about the best I can do. So my final answer for this is 10n plus 12n squared. And this is the end of our lesson. Do me a favor, work on your assigned problems, and I look forward to talking to you. Let me know if you have any questions. Send pictures and photographs, whatever. All right, talk to you soon. Bye-bye.